So this is 2.2, a lesson on direct variation. So the very first thing we have written at the top here, direct variation, is the equation y equals kx. That letter k is taking the place of what we called m yesterday because it has a special term today. It's called the constant of variation. It really still is the same thing as slope. So that's your constant of variation. What makes this a little different from what we were talking about yesterday with y equals mx plus b is none of these are going to have a b because it's a direct variation. It's a direct relationship between y and x. One of the things you will need to be able to do is for some problems you're going to need to find k, the constant of variation. To find k, if you imagine taking the equation and solving for k, you would have y over x. So this is not an extra formula you need to know. As long as you know direct variation is y equals kx, you can always find the equation to find k. So we're going to look at a couple different types of problems and trying to decide if they're direct variation or not. The first one is looking at a table. So when I look at a table, like this first table here, the first thing you need to do is you need to find k for each of the ordered pairs. So to find k, we said we have to do y divided by x. So I'm going to literally do that going down here. So I'm going to do 4 divided by 1, I get 4. I'm going to do 8 divided by 2, I get 4, and I get 20 divided by 5, I get 4. If you notice, those are all the same. That means they're constant. So you now have a constant of variation. My constant of variation is the 4. K equals 4. So then what you have to be careful of, and this is super important in your homework, is you got to make sure you answer the questions. This is going to be a yes answer. So if you look back at the question, it says yes. If yes, state the constant of variation, so that's saying what k equals 4, and write the direct variation equation. To write the direct variation equation, if we go back to the top, anytime it asks for an equation, you have to have the y and the x. It has to look like y equals kx. So to write the equation here, I'm going to write y equals 4x, plugging in that value for k. That's going to be super important on your homework because it's super important in your quiz next week that you answer the question in the problem. So if we zoom in here and look at number 2, again, when you have a table, to decide if it's a direct variation, you have to find k and see if it stays constant. So k is y over x. So I'm going to do 10 divided by 1, I get 10. I'm going to do 22 divided by 2, I get 11. 33 divided by 3, I get 11. So those are not the same, which means this is not direct variation, because we don't get the same constant. So try the next ones I have for you. Alright, now that you've done those problems, now we're going to move on to equations. How do you know if an equation is direct variation? Well, it all goes back to that very first thing I wrote on the first slide. Direct variation is y equals kx. So we're looking for the equation to look like that. Before you can decide that, we have to do what we were doing yesterday. You have to solve for y in all these equations first. We got to get it into y equals form and then decide if it's direct variation. So if we look at number 1, I'm going to go ahead and I'm going to times by 6 to get the y by itself. So I get y is equal to 6x. And then I ask myself the question, does that look like y equals kx? In fact, it does, because all we have is a number here. We don't have anything else. We have a direct relationship between x and y. So I can say yes for this one. And again, follow the directions on your homework. It says state the constant of variation. The constant of variation, k equals 6. So that's the only answer I need for this one. For number 2, again, you got to get y by itself first before you can even decide. So I'm going to subtract the 2. Y is equal to x minus 4. Now this does not look like y equals kx. It looks like y equals mx plus b. So this is not direct variation because you are not allowed to have a b here. No plus b or minus b here. So this is not direct variation. If you look at number 3, in order to get y by itself, I have to get rid of that negative 3. I'm going to do so by dividing. Divide by negative 3, we get y is equal to. This is where it's really important, if you can kind of think of that as 1x over negative 3, we want to write that as a fraction. So that's y is equal to negative 1/3 x. So we can really see what k is. So now this is a direct variation. There's no adding or subtracting going on. So I can say yes. And now clearly I can see that my constant of variation is that fraction I pulled out, negative 1/3. For number 4, again, y should be by itself to decide. It should look like y equals kx. It does not look like that. I got to get rid of the fraction. To get rid of the fraction, we use the reciprocal. So I'm going to times by 3 over 2. I get y is equal to 3 over 2x. No adding or subtracting going on, so this is a direct relationship, so I can say yes, and the constant of variation, to answer the question, is 3/2. Alright, try these next couple of problems. Alright, the next type of problems we're looking at is finding missing values. In a direct variation problem, the constant of variation should always remain the same, constant. So what that tells me is if we use a proportion to find the missing values, any y paired with any x should come out. If I pick a point, y and x, and then I pick another point, y over x, they should come out to be the same. So our proportion we're going to set up is y1 over x1, those that go together, is going to equal to y2 over x2. So all you have to do here for number 1, if we were trying to find x, we have 3 other values, is just set up a proportion. What's really important is the first set, the negative 4 for y and the 25 for x, has to stay together. So it's going to be negative 4 over 25 is equal to, I did y over x, so I need to follow the same order for the second fraction, so it has to be 10 first over x on the bottom. So then we cross multiply here. Remember cross multiplying from Algebra 1 in geometry, you get negative 4x is equal to 250. We divide by negative 4, and we get x is equal to negative 62.5. And then we do the same thing for the next problem here. Again, I like to go, k is y over x, so I try and always go y over x. So I'm going to do 12 over 15 for the first fraction, equal to y over 3 for the second fraction. Cross multiply here. 15y is going to equal 36. And then solve for y. Divide by 15, divide by 15. And you get y is equal to 2.4. So if you're trying to find a missing value, all you're going to do is set up a proportion. Try these next problems. The last type of problem we're looking at is how to graph a direct variation problem. So we're going to do that using a table. So this technically is a direct variation equation, y equals x divided by 5, even though it's division, because if you think of it as a fraction, you get y is equal to 1/5 x. So the constant of variation would be 1/5. So you can pick values for x, but you can pick anything, so pick nicely. If I'm going to divide by 5, I want to pick something like 10. 10 divided by 5 gives me a y value of 2. You're just plugging in to find the y values. I can pick 5. 5 divided by 5 is 1. I can pick 0. 0 divided by 5 is 0. And then you should pick some negatives too. So negative 5 divided by 5 is negative 1. And negative 10 divided by 5 is negative 2. So on the homework you have a little bit of freedom here. So then all we have to do to graph it is graph each of those points on the graph over here. So if I zoom in, the first point was over 10 up 2. The second point was over 5 up 1. Then we had 0, 0. We had over negative 5 down 1. And we had over negative 10 down negative 2. So then I just draw my line through there. And you're going to notice some things we talked about yesterday. It has a positive slope. And the other thing you should notice is that the one major thing here is it's always going to go through the origin. Any direct variation problem, all direct variation graphs go through the origin. That's because they vary directly. Any one that varies directly isn't going to have a b, so they're always going to start at 0, 0. Alright. So answer this last question and you're all finished.